Last time we left off in the middle of section 5.2, and we have just a little bit left to talk about. And in particular, what we're going to talk about is what happens when we have fewer than, in particular, 2. We have 2 equations instead of having 3 equations with 3 unknowns. So we're going to take a look over here at an example like this. You'll notice the directions are slightly different. It says find 3 solutions. It also tells you to write the solution set in the form, and there's a blank and a z, where z is a real number. So as we take a look at this, what we're going to do is it looks very similar at the beginning, but you'll notice, of course, that we only have 2 equations to deal with. So as we're trying to do these 2 equations, what we want is we want to not eliminate z, in particular because there's a z right there, of course, right? So we're going to not eliminate the z as we do this. So we can choose to eliminate x or to eliminate y. I'm going to choose for us that we're going to eliminate the x on this one by multiplying the second equation by a -2. So in the first equation, it will stay the same at 2x minus 3y minus z equals -9. In the second equation, everything's going to be multiplied -2. So this is -2x, and then positive 2y, and then we have positive 2z equals -6. So when we add these together, just like we had on the earlier ones in class today, the -2x's cancel out. And then as we go down the line, I have -y, I have positive z, and I have equals -15. So what we're going to do is we're going to actually solve this now for the y. It'll still have a z in it, of course. It'll say y equals something, and it'll have a z in it. And that's how we're going to fill in the blanks at the beginning over here at the blank z spot. So as we take a look at this one, we're going to subtract the z to their sides. This is -y equals -z minus 15. And then, of course, we're going to divide everything by -1, so we get y equals z plus 15. So what that does is that fills in the blank in terms of y. So we have the y value now in terms of z. It's z plus 15. Now we're going to go back to those same set of equations that we had at the very beginning, and we're going to eliminate the y this time. So if we were to eliminate the y, we would multiply again the second equation, and the second equation would get multiplied in this case by a -3. So I'll do this just underneath the ones I've got. I already have 2x minus 3y minus z equals -9, and now I'll multiply everything by -3. So this is -3x, positive 3y, positive 3z, and it will equal a -9. Okay, so of course the goal was to cancel out the y's, which we did, and we have left here a -x, a plus 2z, and it equals -18. As we're looking at this, our goal then is to... All right, so just like on the last one when we solved for y, now we're going to solve for x. So this is -x equals -2z minus 18. And if we divide by a negative, we get x equals 2z plus 18. All right, so as we're looking at our ordered triple, our x value is 2z plus 18. Our y value is z plus 15. And then z is our z value. And as we're looking at this, we need the rest of the details around it, the curly brace, the bar, and then the statement at the end that says z is a real number. So I'm kind of running out of space. Let me move this over just a little bit. And we'll say z is a real number. Now, I'll just use the number sign for now because I'm running out of space over here. But notice it actually told us to find something else too. We found the solution set in this form. I mean, that's kind of where I started, because even though that's the second part of the directions, if I do that first, the other part will actually be easier. Then where it says find 3 solutions is pretty easy, because all I have to do is plug in a value for z. And if I plug in a value for z, I can figure out what the x value and the y value will be automatically. Let me see if I have a blank slide. I don't. Okay. Let's see. Let's just shrink all this down a little bit. Let me see, just a second. Okay, so here's this. And then we'll do the same thing with the part at the top here. Oops, hang on just a second. Sorry, guys. Okay, So there we go, and we're going to pick values for z. So I'm just going to pick some really nice easy values for z, like 0, 1, and 2. You can pick anything you'd like because it says just to find 3 solutions. But if I plug in 0 for z, then I will have 15 here in the middle, and I will have an 18 at the beginning. If I plug in a 1 for z, that will be a 16 in the middle, and then I would have 18, 19, 20 at the beginning. If I plug in a 2 for z, I would have 17 in the middle, and then I would have 4 plus 18 or 22 at the beginning. So that's how we can get those really quick and easy if we've already got the triple established with the 2z plus 18, z plus 15, and z. All right, so we're going to try another one of these, very similar process, just to give us a couple, another example, 2 examples to work with as you're doing your homework. Okay, so on this one you can see some really nice things. Again, we don't cancel the z. That is not our goal. Now, it may end up accidentally happening, but that's not our goal. Our goal is to cancel either the x or the y. So take a look. We'll just cancel the x's first because they're so nicely defined there that I don't even have to change anything. And I'll just do it over here on the left-hand side first. So I have negative 2x plus 2y minus z equals 4. And I have 2x minus y plus z equals 1. So the 2x's, of course, add to 0 on the first part. I have a y in the middle. And interestingly enough on this one, the z's also cancel. And so you might be like, well, now wait a minute, you said not to cancel the z. And that's true. I didn't want necessarily to cancel the z, but it just happened as I was canceling the x's. The cool thing about this is that actually tells you that the y value always has to be 5 on this one. So if we're filling these in on those directions as we did before, we know that that middle value must be a 5. And so it's going to be concretely 5 no matter what the z value is. We can do the same thing now by canceling the y's. If I multiply the second equation by 2, the first equation is negative 2x plus 2y minus z equals 4. The second equation will multiply by 2, so this is 2x minus 2y. That's going to cancel, I'm sorry, not 2x at the beginning, 4. Get that one right, 4x. And then minus my 2y plus 2z equals 2. The y's cancel. That was our goal, remember. And then we have 2x here plus z equals 6. I'll move my z, so this is 2x equals either negative z plus 6 or 6 minus z, whichever you prefer. And then we'll divide by 2. So this one doesn't actually end up canceling and looking really nice. I mean, we could cancel the 6 if you want, but then we'd have a z over 2. So I'm just going to choose to leave it as 6 minus z. Make sure your z looks like a z and not a 2 over the 2. So my ordered triple up here would say 6 minus z over 2. And then, of course, just like earlier, again, I'll move this over to give me some more space, we need the curly brace at the beginning, we need the line at the end, and let's say that z is a real number. Okay, and I'm certainly shortcutting right the number sign there. And then we're going to find 3 ordered pairs. And again, it's very nice to let those ordered pairs be friendly values. In particular, I like the value for z to be 0. That's very friendly. Notice again, the y value is always going to be 5, doesn't matter what I pick. So there's a value for 0 here. If I put in 0 for a z at the x value is 6 minus z over 2, I'd get 6 over 2, which is 3. I can do another value. Again, 5's in the middle. It's not really useful. I mean, like we could write in there 1 if you want, but then I get an odd number. 6 minus 1 was an odd number, so it's kind of nicer to choose something that's not a whole number, or not going to be an even value on the top. So, an odd value on the top. So let's try 2. So if I plug in 2, 6 minus 2 would be 4, and then 4 divided by 2 would be 2. So we get 2, 5, 2. And then, again, choose something nice. It kind of might be nice to actually just let z be 6. If I let z be 6, we'd have 6 minus 6 on top, divided by 2, and that would be 0. So that would be 3 possible other solutions.